Okay, so continuing our revision, recap of chapters the last moment. Now coming to inequalities. Suppose we have -2 less than or equal to x less than 4. So we can do it in different ways, isn't it? That is, depends on what is the replacement set, and we can solve for this. Let's say it's n. Okay, so replacement set, I'll just write here replacement set. Then we have the solution set and the representation. So suppose it's n natural numbers. So natural numbers start from 1. So 2, 3, you will not include 4. Then if it's whole numbers, of course, you include 0, 1, 2, and 3. Then I or z both can represent integers. So integers, because you're including -2, it's a slack on the left side. -1, 0, 1, 2, 3. You will not include 4 because it's a strict inequality towards the 4 side. And if it's real numbers means anything that can be represented on the number line. So we can show that on the number line. Like, well, yeah, I will do this here. See, it's a represented. So if it's natural numbers, it's simple. You will start with you can put -1. Just put 1 or 2 points on either side. 1, 2, 3, and then show them. This is the solution set. For whole numbers, the only difference is you'll include 0 as well. 1, 2, 3, 4. So you'll be including 0. Then for integers, you will be including 0, 1, 2, 3, 4. Then -1, -2. You'll include -2, okay? And then you'll include -1. You'll include 0, 1, 2, and 3. For real numbers, yeah, you will have to draw the number line. So you can show -3, -2, -1, 0, 1, 2, 3, and 4. So here you include -2, right? So what you can do is you include -2, and then go all the way up to 3. You will go all the way up to 4. You can show like this, or you can draw here and you can show an open circle here at the 4 end. Okay, so here it will be, and here you include -2, and here you exclude. So you can show it as an open circle, and all of this is shaded here. So all the numbers, all the real numbers on the number line. So this is what it is. Then you need to remember just few things here. Two things. See, if you have something like, let's say A is greater than B. Okay. Now whether C is positive or negative, it doesn't matter. A plus C will be greater than B plus C, or A minus C will be greater than B minus C. Now, if A is greater than B and if C is positive, then A into C is greater than B into C. But if A is greater than B and if C is negative, so now what I'm going to do, I'm multiplying by a negative quantity, A into C, B into C, swap the position or change the position of the inequality. It changes. If the same thing hold good even if it is slack. That you need to remember. Same thing. Suppose I have A is greater than B. If C is positive, then if I divide by a positive number, the inequality doesn't get affected. But if I divide by a negative quantity, C is negative, then A by C will be less than B by C. Okay, so that you need to remember. So if I say -x is greater than -3, I can't, see in equality, I will cancel out. Therefore, x is 3, I can say. I can do this in the case of inequality. Remember, if I'm going to multiply both sides by -1, I have to change the position. So it becomes x is less than 3. It makes sense, isn't it? 2 is less than 3, -2 is greater than -3. And as we go on the number line, as we go towards the right, I told you to remember the word more for right. Yeah, we're going to more the greater number, larger number, or more. More, it represents more towards the right. R for right, R for more. As we go towards the left, we are going towards the lesser number. So that you need to remember. Okay, this is what it is with regard to inequalities. Now let's move on to matrices. So matrix is an arrangement of numbers in rows and columns. So we have different ways of denoting matrices, isn't it? Different types of matrices. That is, you have rectangular matrix, square matrix, rectangular matrices, and the number of rows are not equal to number of columns. Here, how many rows? Rows means horizontal, columns means vertical. So 2 rows and 3 columns. This is a 2 by 3 matrix. If I have another matrix where I have 1, 4, 7, 2, -1, 0, you have 3 rows, so it is and 2 columns, so 3 by 2 matrix. So these two are rectangular matrices. Then I can have another matrix where I can have some numbers like this. So 2 rows and 2 columns. So it's a square matrix of order 2 by 2, or we can say order 2. Then suppose you have a matrix, let's say A, which has many columns, but only one row. See, row is only one. So this is a row matrix. The order is 1 row cross 4 columns, right? Likewise, we can have a matrix where 7, 8, 2, 1. Let's say I have 4 rows, but I have only 1 column. So 4 by 1. So this is a column matrix. Okay, column matrix. It's also called as a column vector. Likewise, row matrix is called as row vector. And that we'll keep it aside now. And suppose I have a matrix which is, let's say, 2, 3, 1, 4, 5, 6. What is the order? 2 rows and 3 columns. The transpose of the matrix, I can show it in this manner, is when I interchange the rows and columns. So first row will be written as first column. The second row will be written as second column. So I get 3 rows now and 2 columns. So the order has swapped. That is, 2 by 3 becomes 3 by 2 in the transpose. Okay, this also I know. Then matrix addition is, when you want to add, you should have the same order. So if A is, let's say, 2, 3, 4, 5, 6, 7, then if B is 1, 2, 3, 4, 5, 6, just for an example. So 2 rows and 3 columns. Even B has 2 rows and 3 columns. We can add them. Okay. So we can only add if they are the same order. Then you have to add the corresponding elements. 2 plus 1. So you'll be adding 2 plus 1, 3 plus 2. Likewise. So you'll be adding the corresponding elements. 3 plus 2 is 5. 4 plus 3 is 7. 5 plus 4 is 9. 6 plus 5, 11, 7 plus 6, 13. Adding the corresponding elements in the corresponding positions. Okay. So that is about addition. Likewise, subtraction also. We have seen this. Then when are two matrices said to be equal? When they have the same order and have the same elements in the corresponding elements. If I have A is equal to A, B, C, D, then if I have B is equal to A, B, C, D, A is equal to B, because they are the same order, 2 by 2, and they have the same corresponding elements. Suppose I have C as A, C, D, B. Elements are same and it's 2 by 2, but A is not equal to C and B is not equal to C because the corresponding elements are not identical. That is about equality of matrices. Then matrix addition is commutative. Matrix multiplication is not commutative. So when I have two matrices, we'll see this when we do the multiplication. So first of all, okay, A plus B is equal to B plus A. And matrix addition is associative. A plus B plus C, I can, perform A plus B addition, then is equal to A plus B plus C. I can do the B plus C, and then to that I can add. And of course, when you add or subtract two matrices the same order, the order is not changed. You get another matrix the same order. So that is it. Then you have null matrices where each element is 0. You can have square matrices which are null. You can have rectangular matrices which are null, and so on. All the elements are 0. It's also called as a 0 matrix. And any matrix added to the 0 matrix, the same order, will give me back the original matrix. That is like number 0. It is analogous to a number 0 in the real number system. So 0 matrix means you get back the, it is the additive identity. Then multiplicative identity. Before that, let me just talk about the additive inverse. Suppose A matrix is 2, 3, 4, 5. The inverse matrix of A will be minus A. Additive inverse matrix will be minus 1, minus 3, minus 4, minus 5. That is, when I add the two matrices, I'm going to get null matrix. This is all quite simple. We'll be moving on to multiplication. Before that, there is one more type of matrix called diagonal matrix. So in diagonal matrix, it will be a square matrix. Suppose I say 3 by 3 matrix. Okay. So all the elements will be zeros except the leading diagonal elements. Principal diagonal elements are the leading diagonal. So A, B, C. Then I have zeros all over here. So you see this diagonal position. Only there are some elements, non-zero. Then it is called as a diagonal matrix. And then other positions we have zero. So it's a diagonal matrix. Okay. So only the principal diagonal elements, they will be non-zero entities. And if all the elements are 1 here, the 3 in the diagonal matrix, this matrix is called as identity matrix or the unit matrix. It has to be a square matrix, it has to be a diagonal matrix, and it has to be like this, all ones in this diagonal position. So it's a 3 by 3 matrix. You can have an identity matrix of order 2 by 2 also. So one more thing is, this identity matrix is called as the multiplicative identity. It is analogous to a number 1 in the real number systems. Like 3 into 1 is equal to 3. Any matrix multiplied with the identity matrix of the same order will give me back the, in this case it's commutative. Okay, it will give me back the original matrix. Remember one thing, matrix multiplication is not commutative. A into B will not be equal to B into A. It might hold good in some cases, some combination of elements, but not always. So in a general sense, matrix multiplication is not commutative. And suppose I have A is equal to matrix B, let's say. So now just I can multiply A with C, and I might get B into C, and I might get the two matrices equal. It doesn't mean A is equal to B. I mean, I can't cancel out. It's not like 3x is equal to 3y. In this equalities, we say in the number systems that cancelling out 3x is equal to y. With matrices, we cannot say that. AC is equal to BCC does not necessarily imply that A is equal to B. That you need to remember. Yeah, and when they give you sums on addition, something like 3 plus x, 5, 1, 4, let's say, and something like 7, 3, 7, 5, 1, and 4. So, especially in MCQs, when they ask you just whatever is the unknown, 3 plus x, you have to solve for x, no? So just look at the corresponding element position on the other side. It is 3 plus x, that is 7, right? So don't have to go and match other things. 3 plus x is 7, or x is equal to 4. Okay, this is about the thing. And the scalar multiplication is, if I have a matrix 1, 2, 3, 4, if I'm going to multiply it with the scalar, let's say 5, 5 into A is 5 into, you're multiplying each element by 5, 5, 5 2s are 10, 5 3s are 15, 5 4s are 20. Then matrix multiplication, we have seen A into B, 1, 2, 3, 4. Then let's say B is 4, 1, 3, 2. See, here we can multiply the two matrices because they are the same order. But there's another condition. Okay, here I'll just take you to that. See, when I'm going to multiply two matrices, let's say I have a matrix, one condition should be satisfied. So let us say this is M cross n, m by n, and matrix B will be n by p. Meaning to say, when we have to multiply two matrices, they are compatible or conformable for multiplication, provided number of columns of the first matrix is equal to number of rows of the second matrix. If this condition is satisfied, and then I will get another matrix where the rows will be m and the column will be p. Okay, so this is the thing that you need to remember. So let's say I have 2 by 3 and matrix B is, let's say, 3 by 5. So this is conformable for multiplication because columns of A is equal to rows of B. I get another matrix C where the rows will be 2 and the columns will be 5. So that is how it is. Be very careful in this. And matrix multiplication is distributive. That is, A, if I am going to add B and C and then multiply that resultant by A, it is as good as A into B plus A into C. The same thing holds good with the negative sign as well. And matrix multiplication is also associative, provided they are defined. So A into BC, if BC is defined, and that A is defined with this. If B into C is going to give me one matrix, and that matrix is conformable with A, this is also good as AB into C. So matrix multiplication is associative, provided they are suitably compatible for multiplication. Yes, this is about multiplication. So just to give you an example, 2, 3, 4, 5. B is 1, 0, 2 minus 1. I'm just taking two simple ones for simplicity. I'm going to multiply them. So 2, 3, 4, 5, 1, 0, 2 minus 1. So of course here it is 2 by 2. So the resultant matrix will also be 2 by 2. 2 into 1. So first row, first column, first row, first column. So 2 into 1, 2 plus 3 into 2, 6. Similarly, 2 into 0, 0 plus 3 into minus 1, minus 3. Then 4 into 1, 1 plus 5 into 2 is 10. Then second row, second column, 4 into 0, 0, 5 into minus 1, minus 5. That will be 8 minus 3, 14, 6 plus 2, 8, minus 3, 14 and minus 5. Okay, so this is about A into B. Next is AB is not equal to BA. Suppose I have A is, let's say, 3 by 2 and B is 2 by 2. It's still conformable for multiplication. I'll get a matrix C which is 3 by 2. Okay, that you need to remember. Yeah, so we can have problems like this. That is, whenever they give you like x, 5, 2, 3 plus 7, 8, 5, 1. And they're going to ask you to solve for this, okay, and get the value. So you don't have to look at the other positions, because suppose the unknown is x. Only look at this position and map it. You'll be saving time. So x plus 7 is equal to 9. X is equal to 2. Okay, these are just simple things so that you save on time. Okay. Matrix multiplication we have covered. Okay, then I'll just move on to reflection. A reflection is what? You know that equation of x-axis and y-axis. What is the equation of x-axis? Y is equal to 0. Equation of y-axis is x is equal to 0. They meet at the origin, isn't it? So primarily in like in MCQs, what they can ask you, they can give you a point, let's say 2, 3. When you reflect 2, 3 about the x-axis acts like mirror. So the sign of the x coordinate doesn't change. So 2 remains as 2, only 3 becomes minus 3. You can see here. So I'll get a, I'm reflecting about x-axis. I get a new element, let's say new point P dash. It will be 2 comma minus 3. It's a mirror image. That is, the x-axis acts like mirror. Likewise, if y-axis acts like a mirror, there will be no change in the y coordinate sign. So it will remain as 3. 2 becomes minus 2. And if I'm going to reflect the same point about the origin, both will change. Okay, suppose I'm going to say P triple dash is the new point, minus 2 and 3 will become minus 3. Both the x and the y coordinate, it is axis and ordinate, both will change the sign. Okay. Then you need to be careful that when you plot points, they can give you certain points and they can ask you to plot. So when you plot suitably, you'll be joining the points and you'll be getting something like this. It could be an isosceles trapezium, or it could be a kite. Like if these two sides are equal and these two sides are equal, it could be a parallelogram. So please plot properly so that you get the right figure, and reflection carries sufficient marks. It's very scoring. So plot it up suitably. Remember, when you reflect it about x-axis, the x-coordinate will not undergo change. When you reflect it about y-axis, the y-coordinate will not undergo change. And this is one thing. And suppose you are plotting and you're going to get some, let's say, an 8-sided polygon. You can say octagon if you remember. Otherwise, write it as 8-sided polygon. Don't say anything else. Or 9-sided is nonagon. Don't use words like fish and all this because they are non-mathematical, non-scientific terms. So you can say quadrilateral, but best is if you're able to specify what kind of quadrilateral it is. That is even better. If it is 6-sided hexagon, 5-sided pentagon, 4-sided quadrilateral. Quadrilaterals, like they can be parallelograms, they can be kite, it can be an isosceles trapezium, or just, depends. And suppose I have a line like this, point like this, 1, 2, 3, 4. Now, when I say x is equal to, let's say 3, x is equal to 3 is a line parallel to y-axis, remember. So this dotted line is x is equal to 3. Similarly, if I want to show some other point, y is equal to, let's say, -1, -2, -3. So if y is equal to -2, it is a line parallel to x-axis. Y is equal to -2. So you need to remember this. Suppose I have a point here, 1 and 2. I'll just take a point, 1, 2. You can see this point. I'll name it as A. Now, I want to reflect it about the line x is equal to 3. So then what you have to do, you have to imagine that x is equal to 3 acts like mirror. So the laws of reflection, same thing. However far is the object, that from the mirror, that far is the image. So here it is 1 jump, 2 jump, right? Similarly here 1 jump and 2 jump. So this point will be 5. So the reflected version is A dash, which is 5 comma, it will come here, right? So it is 5 comma 2. So it will be 5 comma 2, you can see. So here it is not about x-axis or y-axis, but you have reflected it accordingly. So we need to remember these things. Okay, you can just go with the number of jumps. From 3 to 1, there are 2 jumps, right? 3, 1, 2. Likewise, from here you take 2 jumps, 1, 2, and this will be your point. This is what you need to remember with respect to reflection. Okay, then I just move on to the next topic, which is proportion. So when two ratios are equal, I can say they are in proportion. So if A by B is equal to C by D, I can write it as A is to C is same as B is to D. This is the way of representing. Okay. So in this case, A and D are the extremes and B and C are the means, isn't it? These are the extremes, ends, and middle one, that is the means. So product of extremes is equal to product of means. If I say A by B is equal to B by C, it means A, B, C are in continued proportion. They are in continued proportion, and what can I say? B is the mean of A and C, or B square is equal to AC. Okay, and similarly, A by B is equal to B by C. So C is the third proportional to A and B. Here in this case, what happens? C is the third proportional to A and B. That we need to remember. Next is properties of proportion. If A by B is equal to C by D, invertendo is just inverted. B by A is D by C. Next, this is invertendo. With this box as a reference, this proportion. Then I can put C down and I can swap the positions of B and C. That means the mean positions. Then it becomes alternando. I'm alternating, isn't it? It is alternando. Then I can say A plus C, A plus B by B. What I've done is I've added 1 both sides is equal to C plus D by D. C by D, I'm adding 1 to both sides. So this is componendo. Likewise, when you subtract 1 from both sides, you get A minus B by B is C minus D by D, which is dividendo. So all these are properties. What is very important, which is very often used, is A by B is equal to C by D. Therefore, A plus B by A minus B is equal to C plus D by C minus D. This is widely used. It is componendo and dividendo. Remember this. Then you can have a question like, yeah, what number must be added to this string of 4 numbers to make them proportional? So right now they're not proportional. It is apparent, isn't it? 6 by 15 is not equal to 20 by 43. So I'm going to add a number so that they become proportional. Let us say I'm adding x to each one of them. So 6 plus x, 15 plus x is 20 plus x by 43 plus x. Okay, so now I'm adding this and I can cross multiply, isn't it? So 43 plus x into 6 plus x is equal to 20 plus x into 15 plus x. And I just have to expand this. So this becomes 252 plus 43x plus 6x plus x square is equal to 300 plus 20x plus 15x, that is 35x plus x square. X square gets cancelled out on either side. Next is 49x plus 252 is equal to 300 plus 35x. So you can shift it here. It becomes 14x is 40. 258 it is. Yeah. Be very careful with this because it can lead to different things. Yeah. So yeah. 49 minus 35 is what? 14x. 14x is 300 minus 258 is 42. X is equal to 3. This is one way of, yeah, this is one kind of problem that can be asked. So then they can ask you using properties of componendo and dividendo, or they'll say either they will say using componendo dividendo or using properties of proportion. Solve for x given root of 3x plus 4 plus root of 3x minus 5 upon root of 3x plus 4 minus root of 3x minus 5 is equal to 9. So when you use componendo dividendo, you get I'll solve it. So it will be A is this, right? A plus B by A minus B. That is A minus B. A plus B by A minus B is, so it's like A by B. Remember, I'm writing 9 as 9 by 1. A by B is equal to C by D. So by applying component of dividendo, A plus B by A minus B is C plus D by C minus D. So it's 9 plus 1 by 9 minus 1. So what happens? You get 3x minus 5 and they get cancelled out. Okay, so it will be 2 into root of 3x plus 4 divided by 2 into root of 3x minus 5 is 10 upon 8. 2 cancel out, which is 5 by 4. Okay, so it will be 3x. You're squaring both sides now. The root and the square goes away this side. 3x minus 5 is 25 by 16. And now you can cross multiply. So 48x plus 64 will be 75x minus 125. Okay. Then we can shift it. So 125 plus 64, which will be 189, is 75x minus 48x, which is 27x. So x is 189 by 27, which is what? 7. So x is 7. So this is an example, or this is, we solve A by A, where we can solve for this problem. We're solving for x. Okay. So you're going to get A by B is equal to C by D, A plus B by A minus B, C plus D by C minus D, using componendo and dividendo.